Yeah, hi Max.
Hi,
How are you today?
I'm fantastic. How are you?
Good. Must have a big test coming up.
Yeah.
Okay,
Yeah.
let's
Um,
start it. What's up first?
let's do, I know conversion between degrees and radians.
Okay.
Know that. Angles and standard position and coterminal angles, I know that. Circle, arc length. I don't know how to find circle, arc length, or sector area.
Okay. Let's talk about arc length. I kind of screwed you up on this one day. I got confused about it. Whoops. So the formula is S equals R theta. That's if it's in radians.
Okay.
Obviously, if it's in degrees, you need to apply the pi over 180. In other words, if it's in degrees, that's what S is. And S is a measurement of the length of that arc. If you were to cut a piece of string and pull it straight, it would be how long it was. It's a linear dimension. Okay.
Right.
So if you have, say, a radius of 6 and an angle of pi over 6, which would be what, 30 degrees? Then the length of that arc is 6 times pi over 6. So it would be that. Now, notice that the arc length of the entire circle is the same as circumference. Well, what is circumference? Circumference is 2 pi r. Well,
Okay.
arc length of the entire circle, this angle all the way around would be 2 pi in radians. So it matches. This is the same as that, which is the same as that, only arc length for an angle smaller than 2 pi, smaller than 360 degrees, then you can always find it by that formula. Or, like I said, if it's in degrees, you need to add the conversion factor to it.
So S is arc length.
S is arc length, exactly. Now let's talk about sector area. Okay, if I want to know the area of that, well, what's the area of the circle?
Pi r squared.
And what percentage of the circle is that? It's that angle in degrees divided by 360.
Or divided by 2 pi. 2 radians. 2 pi radians. Right?
Right, yes, absolutely. Same ratio. In other words, if that angle is in radians, you're right, it's divided by 2 pi. And you can see that if that was a 90-degree angle, that would be 1/4 of the circle, and 90 divided by 360 is 1/4. So
Right.
sector, or the area of a sector, I don't think it has its own formula. You basically just use the area of the circle and multiply it by the percentage of the circle that the sector represents.
So it's pi r squared basically multiplied by the size of the portion of the circle.
Yes.
Okay.
If you had all the way around, in other words, if you had 180 degrees, well, that would give you 1/2, which is correct. Or if the angle is in radians, then that's pi radians over 2 pi radians. That's also 1/2.
Okay, that's simple. Definition of ratios. Ricky, sorry, one sec. I'm going to ask my friend something about the
Okay.
last time. All right. So.
Let me just say one more thing about arc length.
Okay.
If theta is 1 radian, then the arc length is the same as distance as the radius. So if this angle is 1 radian, which is about 57 degrees, the definition of radians is this. It's the length of the arc that is subtended is exactly the length of the radius. And you can see why that would be true, because S would be equal to R times 1. So S is equal to R.
All right, that makes sense.
All right, what else? Do you have a review packet, or you just kind of going through the book?
No, I have a review packet.
Okay.
There's no questions in here.
How big is it? How many pages is it?
It's 1 page, but it's just covering what we need to know. It's not covering any actual questions.
There aren't any problems, although I could certainly provide the problems. In other words, if we're going to have a session tomorrow and Sunday, I want some problems to do. So,
okay, do you want me to tell you want to write down what I have?
Well, I tell you what, can you take a quick picture of it?
And text it to you?
Have you done this before?
I have your phone number.
Well, don't send it to my phone, because I can't bring that up on my computer. Send it to my email address.
Okay.
Send it to Gmail, if you have that as one of your options of sharing a photo.
Can I send it to...
And once you type this in, the next time you go to send a photo, you just have to type in the first couple letters, and it'll finish.
What's your email address?
I just posted it. Can you read it?
Yes.
That's a C-O-W-A-N, 1949.
Okay, I got it.
Okay, let me pull up my Gmail. Okay. Holler when you've sent it.
No, I haven't. I'm sending it right.
If you're using an Apple phone, make sure you send it as a large image.
Yes, I know.
Okay. Wonder why Apple's the only one that asks that. If you have an Android phone, it doesn't ask that. I don't have an option. In other words, I send it as an image, and it comes in naturally as a large image. But
all right, I sent it. It should have gone through by now.
Okay. Don't have it either.
Evaluating trig functions for any angle using the reference.
Why don't you go ahead and until that gets here, sometimes it'll take, 15 or 30 seconds if the internet's running slow or something. But go ahead and verbalize the next area that you want to cover, and I can maybe come up with, oh, there it is. Hold on. Okay. So the check mark means what? You're good?
Check mark means yes, I know what I'm doing. But when I sent that, I didn't go through all the things yet. So I know evaluating trig functions for the reference angle and angle quadrant.
Let me give you just a quick test on that.
Okay.
It's the tangent of 225.
225. So the reference angle is, sorry, wait, 225 minus 45 degrees.
Okay. So it's the equivalent of a 45-degree angle as far as the absolute value goes. What's the tangent of 45 degrees?
Let me get out my calculator. Ow! Sorry, it's noisy.
That's okay.
1.
What's the tangent of 45? In other words, the first quadrant angles are ones you should really try to memorize so that you can instantly come up.
45 is 1.
Okay. And now let's determine the plus or minus sign. What quadrant are we in?
First? No,
No, this defines the quadrant.
that's going to be in the third quadrant.
Correct. What's the sign? What is the plus or minus sign on tangent in the third quadrant? What'd you say?
It's positive.
So it's plus 1. Okay. Let me do one more. Are you going to be questioned, or are you going to potentially get a question like this?
Yeah.
Okay, let's do that one.
Okay. So, so the reference angle is 120.
No?
No?
What
Oh, wait. No, 60. 60.
Okay. So I'll put that in parentheses. Like that.
Right.
I don't want to say that the secant of 300 is the same as the secant of 60, but as far as the absolute value of it, it is. And
so the cosine of 60 is 1/2, which means that the secant of 60 is 2.
correct. What's its plus or minus sign?
It's in the fourth quadrant, which means that it is minus, negative. No, sorry, it's positive. It's positive because of cosine.
You've learned this, all students take calculus?
Yes.
Okay. Because it's cosine, that really should be cosine and secant. And that should be sine and cosecant. Because
right.
The plus or minus sign has to be the same for the reciprocal.
And tangent is also with cotangent.
Correct. Correct. So all of those share, any function that's a reciprocal shares the same plus or minus sign by definition.
Right.
Okay. Looks like you can, well, let's try a couple more. I'm not quite done here. Two ways to do this problem. There's the easy way and the hard way. Either one works. Well, either one works. It's just one is a little lengthier than the other.
You can, wait, if you add 180 to that.
Well, I can't add 180. First of all, what quadrant is that in?
That's in the first quadrant.
It's in the fourth quadrant.
Oh, negative?
Negative goes this way.
Right, okay.
Okay, so the reference angle is still 60 degrees, but okay, so let's talk about what you just said. Let's add 360 to it to get a coterminal angle.
Which is 420.
Go ahead, what is it?
Coterminal angle is 420.
No, add 360 to minus 360.
Wait, 360 to minus 360?
Yeah, when you create coterminal angles, you always add 360. So I'm starting with a minus 360. If I add plus 360 to it, I get 300.
Right, okay.
Okay? So that's one way to do it. And these are equivalent. I can say these two things are the equivalent, not just the absolute value, but also the plus or minus sign. notice that that 300-degree angle goes like that. There's 300. And now what would we do? So now the problem becomes we're looking for the sine of 300. What's its reference?
300, the reference angle for 300 is 60. No, I'm sorry.
Yeah.
Yeah. Oh,
it's this angle right there. In other words, if I hadn't have started with minus 60 and I'd have said, let's find the sine of 300, the reference angle that gets created is this 60-degree angle. What's the sine of 60 degrees?
the sine of 60 degrees is 0.866.
No. As a ratio. Don't be using your calculator on these. You're not going to be able to use your calculator on these kind of questions.
Sine of 60 is 3 pi over 2.
No. Let's draw our 30, 60 right triangles. These two triangles are almost fundamental. They're so fundamental to trig and geometry that you should memorize the unit ones. The unit ones are 1, square root of 3, 2, and 1, 1, square root of 2. Now, what that does is gives you the ability to figure out all your first quadrant angles. So what's the sine of 60?
Sine of 60 is 30, well, I'm sorry, is square root of 3 over 2.
Correct. That's the answer. Don't convert that to a decimal.
But I just said that it was the square root of 3 over 2.
Oh, I'm sorry. I must have missed. I didn't hear that.
Yeah, I have that memorized. So.
Well, okay. I didn't realize that. When I didn't hear the answer, I figured I should draw these two triangles again. But yeah, you definitely need to know all three major trig functions: sine, cosine, and tangent of 30, 45, and 60.
Right.
Okay. So let me erase these if you don't need them. But the ability to create these from memory is what, I mean, I guess if you've memorized them all, that's fine, as long as you have them all memorized. Now, what's the plus or minus sign on this answer?
The plus or minus sign is, it's minus.
Okay. That was the hard way to do the problem. Here's the easy way. This is an odd function, meaning the sine of minus x equals the minus sine of x, because it is odd. I can make this statement. Cosine is even. Tangent is odd, but cosine is even. The cosine of minus x is equal to the cosine of x. Okay? So if I make this conversion as my first step, see how much easier the problem becomes? I don't have to add a coterminal. I don't have to do any of that because I know what the sine of 60 is. That's square root of 3 over 2. And I don't go, in other words, that's a first quadrant angle. So it's clearly square root of 3 over 2, but I still got the minus sign, so it gets applied.
Okay.
But it basically is a one-step instead of a three-step problem.
Right, that makes
So whenever you're taking any of the trig functions of negative angles, the easiest way to handle it is to convert it to a positive angle. So the cosine of minus 60 degrees is the same as the cosine of 60 degrees. And that makes sense when you realize that cosine is positive in the first and the fourth, because that's fourth. But it's the same as the first one. So whatever the cosine of 60 is our answer. 1/2. So this odd-even property is very valuable for dealing with negative angles.
All right.
Okay. And I think that's going to cover pretty much. I mean, you don't have any problem with this kind of a question.
No.
Okay, we just take as many multiples of 360 as we can away from it so that it becomes that.
Right.
Okay. Let me look back at that list. These quadrangles, they're called. You know what a quadrangle means?
I don't think so.
It's 90, 180, 270, multiples of 90. Because those two triangles that I drew don't really tell you what the sine of 90 degrees is, or the cosine of 90 degrees, or the sine of 180. In other words, we can't use our little formulas we use because these angles are not in a quadrant. Do you know what the sine of 90 is?
Sine of 90 is 1?
Correct. Let me give you a nice way of memorizing these, and maybe it will add something to your understanding of the unit circle. Turns out...
We finally learned about.
Oh, you finally covered the unit circle?
Yeah, we finally covered the unit circle.
Wow, that's right. You covered the law of sines before the unit circle. Yeah.
Yeah, we learned literally everything else before the unit circle.
Okay. This, that is funny. The coordinates of that point are x and y, right?
Right.
Well, it turns out that if you look at that theta, and since that's 1 because it's a unit circle, and you create the triangle, the cosine of theta is the x over 1. So this is also cosine of theta, comma, sine theta in the unit circle. And I can replace x and y with cosine of theta and sine of theta. And if they want you to memorize the unit circle, they really want you to be able to come up with those two things for all of these angles we're talking about. You don't need to know just if that's a 30-degree angle, then the coordinates of that point are square root of 3 over 2, comma, 1/2. Because the sine of 30 is 1/2, the cosine of 30 is square root of 3 over 2. So they want you to be able to put both of those coordinates down. So I know you have all of them memorized, and that's good, but make sure you know that the x coordinate is cosine of theta, the y coordinate is sine of theta.
Right, I'm going to write that down. And then I actually have to go to lunch for today? I have to go for today?
Okay, let me just say one last quick thing. If you look at that point right there, which is 0 degrees, notice that that's 1 comma 0, right? And since the first one has to be the cosine of 0, the cosine of 0 has to be 1. The sine of 0 has to be 0. By the time we get up to there, we're at 0 comma 1, and that's 90 degrees. So 90 degrees, the cosine of 90 degrees must be 0, and the sine must be 1. So you can use the grid to come up with these all of the quadrangles, 180 and 270.
Right, and of 0 is the same as 180, and 90 is the same as 275. 270.
Let's put what's that point? That point is minus 1 comma 0. So what's the cosine of 180?
Cosine of 180 is minus 1.
Right, it's this number right here.
Right.
What's the sine of 180?
0.
Correct. So as long as you know how to label these, and there's no secret to labeling that, that's 0 minus 1. So from those 4 points, you can figure out all the quadrangles.
Right.
Just knowing those 4 coordinates. And you can always figure those 4 coordinates out.
All right. Thank you.
That's your clue to figuring out what sine and cosine are of the quadrangles.
Yeah.
Okay, good.
All right. So I'll talk to you tomorrow.
You had to leave for lunch right now?
Right.
Okay. I will talk to you tomorrow.
All right. Awesome. Thank you.
All right, Max. Bye-bye.
Bye.